Okay, let's see what happens when we're finding the transformation from a graph. So what we're going to have is a graph of a transformation, and we're going to compare that to the parent function so that we can write the equation that matches this graph. Now, I have the parent function right here for you so that it's kind of sketched out and you can compare it. Forgive me, some of these sketches are interesting. So, I'm looking here at example 10. I notice straight away here is my vertex. So the vertex is at the point -3, 0. So the vertex went left 3. And I notice also that the parabola is opening down. So when I write my equation, the first thing I'm going to want is a negative sign because I want this to open down and I want it to go left 3. So that means I need an x plus 3 in the parentheses. And I'm going to go ahead and square that. Remember, if I don't have an x squared, then I don't actually have a parabola. Now I just need to see if there is a stretch or compress. Now notice in the parent function, from the vertex to the next point, we go over and up 1. So for here, I want to see if that same thing happens. So if I can go over and down 1, and that does. So there's no vertical stretch or compress. This is the equation that matches this function. And you can always graph that in Desmos and double check it. So if we were to double check this, I would put this in Desmos and I would type in my equation, negative x plus 3, oh, not 2, plus 3, 3 squared. And I'm going to have to move my graph over a little bit. You can see there it does match. It has that -3, 0, and so that is a match. Okay. Lost my place. Give me 1 second. All right. So let's go to number 11. Now, number 11 is upward facing, so it should be positive. And I went ahead and notated the vertex. So the vertex is at 3, -5. So I'm going to have to go right 3, so I'm going to do that by subtracting. And then I'd have to go down 5 to get my new vertex. What I need to know is if there is a stretch or compress. Now, from the vertex, if I go over 1, I only go up a little bitty bit. I don't go up an entire step of 1. So there is a stretch or compress. So actually, to see how much, I want to see exactly how much we went up. So I went ahead and put the coordinates of this point here. So the coordinates of this point are listed at 4, -29/6. So we actually go up exactly 1/6. So that is what our stretch or compress is going to be, is 1/6. Thank you. Okay, so let's look at number 12. Okay, so look at number 12. You can see where the vertex is, so go ahead and put the vertex in your equation. Okay, so my vertex here is at 2, 1. So to get that, I need to go right 2, and I need to go up 1. Now I just need to see if there's a stretch or compress. So if I go 1 step to the side, I actually end up going 5 steps up. So I need to go ahead and stretch that by 5, so that I'll go 5 steps up to the very next step. Now this is not a slope, it won't keep working, it only works from the vertex to the next identifiable point. Last but not least, let's look at number 14. Notice that it's facing downward. Go ahead and add your vertex, this is facing downward, then see if you can add a stretch or compress. Okay, so this one is facing down, so I'm going to start with a negative. If I go from the vertex to the side and down, I actually go down 2. So there is a stretch of 2. And then I'm going to add in my vertex. So my vertex was here, 1, 2, 3, 4, 5. So that is 5, 0. So to get that, I had to go to the right 5. And there's the equation. And double check the other one. Yeah, that was right. Okay. And you can always put that in Desmos to check it.